Good afternoon, learners. Today we are going to do revision of numeric and geometric patterns. So this is what we are going to talk about, the presentation outline. We are going to talk about basic technology. We are going to extend patterns. We are going to look at the relationship between numbers, including patterns. We are going to describe the general rule in our own words. We are going to determine the general rule in algebraic language. So, as you know, every time you're going to have a pretest, which is the quizzes. And from there, we're gonna conclude. Okay, so let's look at the basic terminology that we're gonna talk about. We're gonna talk about the term. You must know what is a term. So a term is each number in a sequence or in a number pattern. Okay, now you can ask yourself, what is a pattern? A pattern is an arrangement of numbers or shapes, because like I said, we are going to do number patterns as well as geometric patterns. So we are going to talk about numbers as well as shapes or diagrams. So now consider this sequence 3, 5, 7, and 9. So the first number that is written, we call this, the whole thing 3, 5, 7, and 9, we call it a pattern or a sequence. So the name of the term that is written first, which is term 1, we call it 3. Our term 2 is 5, as you can see by my cursor there. And term 3 is 7, and term 4 is 9. Hi, Sepiso. I can see someone is raising the hand. Are you asking a question? Can I continue?
Ma'am, you can ignore the hands. She cannot.
Okay. No, thank you very much, Paul. Okay, so as I was saying, consider the pattern 3, 5, 7, and 9. So the number written first is 3. We call it term 1. The second one, term 2, which is 5. Third one, term 3, which is 7. And the other one, term 4, which is 9. Good. So now, I was talking about a sequence. Like I indicated, a sequence is the same thing as the number pattern. List of numbers in a certain pattern, we call it a sequence. So we're also going to talk about the general rule. That is, we're going to explain on how a pattern is arranged. Okay. So now let's move to the next slide. So now, as you can see, we have the sequence 3, 5, 7, and 9. Okay. Now, as you can see there, 3, like I indicated, is term 1. So we indicate it like capital T with a subscription there, 2. So in this case, our term 2 equals to 5. So this means that T, the capital T implies, capital T implies the term. 2 there, the subscript 2 indicate the position of the term. And 5 here is the number that represents the second position in the pattern, as you can see there. Okay, so now we must be able to say the rule in words. So what can we say there? 3, 5, 7, and 9 in that pattern. We can start saying add 2 to 3 to get 5, add 2 to 5 to get 7, as you can see. Then we added 2 to 7 to get 9. So that's how you can continue with your pattern to have more terms in the sequence. Okay, so now look at these terms that I've listed here. Term 1 is 3, term 2 is 5, term 3 is 7, term 4 is 9, term 5 is 11, and term 6 is 13, and term 7 is 15. Now, think about this. What is the sixth term? Okay, I think everyone can see term 1, term 2, term 3, term 4, term 5, term 6 will be 13, meaning that the position of 13 is the 6th in the sequence and 15 lies in the 7th position. So we call 15 the 7th term. Okay, now we are going to look at a table because patterns can be shown in different ways. We can represent them in different ways. So now look at the table. My inputs, I have the inputs and the output, as you can see there. Okay, so my input is 1, which represents the term 1, term 2, term 3, and term 4. So if I multiply 1 by 3, if the rule is saying to you, multiply each term by 3. So what will be your output? Your output will be 3, you'll have 6, and you'll have 9. So what will happen to 4? The same way, we're going to multiply 4 by 3, and we are going to get 12. Okay? So now, if we have to describe this in words, we're going to say, multiply the input 3 to get the output, like we did. We multiplied each input by 3 and we got 3, 6, 9. Okay, so now look at my table again. So now what do we have? Okay, like I indicated, we have the input, or we can say position of the terms, or we can indicate that by small letter n. So meaning that I'm having term 1, term 2, term 3, term 4, term 5, and term 10 up to 100. So now term 1, according to my table, is 2. Term 2 is 5. Term 3 is 8. Term 4 is 11. So that's how we can write the terms. We can write them in this way, or we can represent them in a table like that. Okay, now we are going to have activities. So now I'm going to give you some few minutes to look at this activity, but we're going to do it together. Okay, consider the activity, the number pattern that is given 7, 10, 13, and 16. So the first question is saying, state the rule in words for this sequence. So you must be able to state the rule in words. How did we get 10 from 7? How did we get 13 from 10? How did we get 16 from 10? Okay, then now you have to write down the next 2 terms. Okay, so now what is the 6th term of that sequence? As you see, we only given 1, 2, 3, 4. So you want term number 6. And which term of the sequence is 25? And determine the 10th term and determine the general term, as well as determining the 100th term of the sequence. Fine. Okay, so now let's try to answer the question, starting with question number 1. Okay, now we are going to get solutions. So if we start with 7, because 7 was the first number, what must we do? We added 3 to each term to get the next term. Okay, So look at what we had. To 7 to get 10, we added 3. To 10 to get 13, we added 3. To 13 to have 16, we added 3. Good. So now, to answer the next question, what will be the next two terms of the sequence? According to that, will be 19 and 22. Okay, so we move to the next question. The sixth term is 22 because they said, what is the sixth term of the sequence? So now if we move back a little bit, because 6 is not that far. If I add 3 to 16, I'm going to get 19. If I add 3 to 19, I'm going to have 22. And if I add 3 to 22, I'm going to have 25. So they say which term of the sequence is 25? Like I indicated, that will be term number 7. Okay, so now the 10th term will be 34. So it's easy for you to calculate the 10th term because it is not far away from other terms. But now look at this one. Okay, if you have to calculate terms like, let's say, T100 or T50, 50 is far away, so it's very difficult for a person to calculate that. So what we usually do, we do this. Now, we write the term number, which is 7. And as you have seen, the constant difference between my terms was 3. So for you to get the general term, you write term 1, you write 3 as your constant difference, then you write the position of the term. Then from the position of the term, then you add, you ask yourself, what is it? Because 3 times 1 is 3. But for me to get to 7, what must I do? I have to add 4. So now let's look at the other one if it holds for other one. So term number 2 is 10. So our constant difference was 3, but position of 10 is 2. So multiply, link the position to the constant difference. 3 times 2 is 6. But what is it that I can add to 6 to get 10? It is 4. So also this one holds true. So now we go to the third one. We do the same. Term number 3 times the constant difference 3 is 9 plus 4 will give us 13. So that's how you can determine the general term. So now we say, okay, what did we do? Okay, for term 1, we multiplied constant by 3. For term 2, we multiply the constant by 2 and so forth and so forth. Then from there, our nth term will be the common difference times the position of the term, which is n, plus 4. So we can continue generating the terms this way. But unfortunately, sometimes you can be given big numbers like in this question. Like the question is saying, however, if you are required to find the 100th term, this would be extremely time consuming because you can't just add 3, 3, 3 up to the 100th term. So what do we do in that instance? So therefore, we need to find the rule which will help us to do this. And this we call the general rule, as we have seen in question 1.6. Okay, so this is question 1.6, like I indicated. So to find the rule, you write constant difference times the position of the term. Then from there, you ask yourself, how will you get to the term? So sometimes you can add, like in this instance, we added 4, but sometimes you may have to subtract. Okay, so you do that with the second term, multiply it by constant difference, and check what is it you must add to get to that. So this is how you get the general term. Okay. So now let's move further to this. So this is what I already talked about. So the general rule in words, what can we say the general rule is? Is multiply the difference by the position of the term, and in our case, we added 4. Okay? So now we go to geometric patterns. What are these geometric patterns? These are the number patterns represented diagrammatically, meaning that using diagrams. Okay, so now this is what we have. We have some diagrams there, the second one, the third one. So for you to be able to do that, you have to attach a number next to the pattern. So what do we see there? Okay, what do we see there? We see that we have some patterns. If you attach the number to pattern number 1, you will see that in term 1, as you check there, every figure there has a constant difference of 4. So if you multiply each constant difference by the position of the term, for me to get figure 1, I have to add 1. For me to get figure 2, I must add 9, 1. So, and so on and so on. So now, as we check there, what do we have? There are 5 dots in figure 1, and there are 9 dots in figure 2, and there are 13 dots in figure 3, and there are 17 dots in figure 4. So these are the number pattern, meaning that these are the numbers that we can attach to the diagrams. So we'll be having 5, 9, 13, and 17. So if the question is saying determine the general rule will be Tn, or the rule will be 4, which is our constant difference, multiplied by the position of the term plus 1. So for us to get T100, we just substitute to the n, because as you can see, where we had n, we had 100, so we multiply, then we add 1, so the answer will be 401, meaning that there are 401 dots in the 100th figure. Okay, so because now it's about time, we have come to the end of the presentation. Thank you very much, and good luck for your exams. Thank you.